In this video, we're going to break down Kubernetes in a simple and practical way. We'll start with what Kubernetes actually is, using its official definition but explained in plain language. Then we'll look at why Kubernetes even exists in the first place. What problem was so big that engineers had to create an entirely new system to solve it? After that, we'll walk through the basic architecture of Kubernetes, how it's structured, what components it has, and how those components work together. We'll also explore the core concepts you need to understand, like pods, containers, and services, and what role each of them plays. And finally, we'll look at how you actually use Kubernetes in practice by going through a simple configuration example. By the end of this video, you should have a solid mental model of Kubernetes and how it works. So let's get started. So, what is Kubernetes? Kubernetes is an open-source container orchestration platform originally developed by Google. Now, that definition can sound a bit intimidating, so let us simplify it. At its core, Kubernetes is a system that helps you manage applications that are packaged into containers. These containers could be created using technologies like Docker, and they contain everything an application needs to run code, dependencies, libraries, and configuration. But Kubernetes doesn't just run one or two containers. It's designed to manage hundreds or even thousands of them at the same time. And it can do this across different environments, whether that's physical machines, virtual machines, cloud platforms, or even hybrid setups that combine multiple environments. So in simple terms, Kubernetes is a tool that helps you run and manage containerized applications at scale. To really understand Kubernetes, we need to understand the problem it was created to solve. Over time, software architecture evolved from monolithic applications to Instead of building one large application, developers started building many smaller, independent services that work together. Each of these services often runs inside its own container. Now imagine this. Instead of managing one application, you're managing hundreds or even thousands of small containers. And these containers might be running across multiple machines and environments. Trying to manage all of that manually, or with simple scripts, quickly becomes overwhelming. You have to decide where each container runs, monitor their health, restart them if they fail, scale them when traffic increases, and ensure everything keeps working together. At some point, this becomes too complex to handle manually. And that's exactly where Kubernetes comes in. Kubernetes solves these problems through container orchestration. But what does that actually mean? It means Kubernetes automates the deployment, management, scaling, and networking of containers. There are three key features it provides. First, high availability. This means your application stays up and running, even if something fails. Users can access your app without downtime. Second, scalability. Kubernetes can automatically scale your application up or down depending on demand. If more users arrive, it adds more resources. If traffic drops, it reduces them. Third, disaster recovery. If something goes wrong like a server crash or data loss, Kubernetes can help restore your system to its previous state. Together, these features make applications more reliable, faster, and easier to manage. Now, let's look at how Kubernetes is structured. A Kubernetes cluster is made up of nodes. There are two main types: master nodes and worker nodes. The master node is responsible for managing the cluster. The worker nodes are where your applications actually run. Each node in the cluster runs a process called kubelet, which allows it to communicate with the rest of the system and execute tasks. So you can think of the cluster as a coordinated system where the master gives instructions and the workers carry them out. Worker nodes are where the real work happens. This is where your applications run inside containers. Each worker node can run multiple containers, depending on how much workload it needs to handle. If your application grows, Kubernetes can distribute containers across multiple worker nodes to balance the load. So worker nodes are essentially the engines that power your applications. The master node contains several important components. First, the API server. This is the entry point to the cluster. Any command or request, whether from a user, a script, or a UI, goes through the API server. Next, the controller manager. This component constantly monitors the cluster and ensures everything is running as expected. If something fails, it takes action to fix it. Then we have the scheduler. The scheduler decides where to run containers. It looks at available resources and assigns workloads to the most suitable worker node. And finally, this is a key value store that holds the entire state of the cluster configuration data, status, everything. It's also used for backup and recovery. Together, these components make the master node the brain of the Kubernetes cluster. All the nodes in a Kubernetes cluster are connected through a virtual network. This network allows them to communicate as if they were part of a single system. In fact, Kubernetes makes multiple machines behave like one powerful machine by combining their resources. Worker nodes usually have more resources because they run applications. Master nodes, on the other hand, are critical for control. That's why in production environments, you often have multiple master nodes. If one fails, others can take over, ensuring the cluster continues to function. Now let's talk about one of the most important concepts in Kubernetes: pods. A pod is the smallest unit you work with in Kubernetes. It acts as a wrapper around one or more containers. In most cases, you'll have one pod per application. Sometimes, a pod may contain multiple containers, for example, a main application and a helper container. Each pod runs on a worker node and has its own IP address. So you can think of a pod as a small, self-contained server. Pods are designed to manage containers automatically. If a container inside a pod crashes, the pod will restart it. This makes the system self-healing. However, pods themselves are temporary. They can be created and destroyed at any time. When a pod is replaced, it gets a new IP address. And that leads us to the next concept. Since pods can change frequently, relying on their IP addresses isn't practical. That's where services come in. A service provides a stable way to access a group of pods. Instead of connecting directly to a pod, you connect to a service. The service then routes your request to the appropriate pod. It also acts as a load balancer, distributing traffic evenly. So even if pods are created or destroyed, the service remains constant. This makes communication between components reliable and predictable. So how do you actually use Kubernetes? Everything in Kubernetes is configured using files, usually in YAML or JSON format. These files describe what you want the system to look like. You send these configurations to the cluster through the API server. This can be done using command line tools, scripts, or user interfaces. Kubernetes then takes your instructions and works to achieve the desired state. One common configuration is a deployment. A deployment defines how many instances of your application should run. For example, you might specify that you want 2 replicas of your app. Kubernetes will then create and maintain those 2 pods. You can also define details like container images, ports, and environment variables. This makes deployments a powerful way to manage applications. One of the most powerful features of Kubernetes is its self-healing capability. You define the desired state, for example, 2 running pods. If one of those pods fails, Kubernetes detects a difference between the desired state and the actual state. Then it automatically creates a new pod to restore balance. This happens continuously, without manual intervention. And that's Kubernetes in a nutshell. You've seen what it is, why it exists, how it works, and how to use it. With this foundation, you're ready to dive deeper into Kubernetes and start using it in real projects. If you found this helpful, don't forget to like and subscribe so you won't miss the next one. It really helps to support the content. And let me know if you want more videos like this. Thanks for watching, and I'll see you in the next video.